Good morning, sir. Good morning, classmates. Today we are presenting the determination of aldehydes in fish by high-performance liquid chromatography.
Secondary breakdown products of unsaturated lipids are volatile aldehydes. During the frying of food, large volumes of these volatile chemicals can be created. They contribute to fish having a fishy odor. However, large concentrations of this sort of chemical can cause alterations in them. According to the article, large levels of volatile aldehydes can cause taste, color, texture, and odor changes in fish.
Foods that are exposed to volatile aldehydes become rancid and lose their nutritional value. Because most aldehydes are harmful to the human body, inhaling excessive amounts of these molecules can cause respiratory problems.
Because fish is a key source of food for people throughout the world, this research is important because it developed a unique technique of identifying traces of volatile aldehydes using high-performance liquid chromatography in the form of 2,4-dinitropenyl hydrazone derivatives. Acetonitrile and ethanol were used to conduct the technique. Purified water was obtained by distillation and filtration using an E-Pure Altex system. The 2,4-DNPHI solution was prepared with acetonitrile H2O H3PO4. This was then purified using a liquid-to-liquid extraction method with CCl4. HPLC UV analysis was used to establish the purity of the solution. The DNPHO derivatives formaldehyde, acetaldehyde, propanol, butanol, pentanol, and hexanol were produced by reacting 2,4-DNPHI with corresponding carbonyl compounds. A stock solution comprising of a combination of hydrazone derivatives was generated by first weighing each hydrazone derivative and then dissolving it in acetonitrile. The cartridges were injected with 4 ml of 2,4-DNPHI solution after being washed with 2 ml of acetonitrile for preparation. The cartridges were blasted with N2 to ensure there was no surplus liquids.
The fishes were purchased at a local store and washed with distilled water and a saturated NaCl solution. Their flesh was then blended into a fine puree in a food processor. Until it was tested, the puree was stored in a 15 degrees Celsius sealed polyethylene bag. 2 SEP-pack C18 cartridges coated with an acid solution of 2,4-DNPHI were used to purge aliquots of created fish samples in a 500 ml glass recipient with N2 for 40 minutes. The 6 carbonyl compounds were trapped and detected because of this. The treated compounds were eluted with acetonitrile and the 2,4-DNPHO produced was isolated and quantified by HPLC UV analysis. A Zorbax ODS 5 micrometer column was used to separate the compounds, with an acetonitrile water combination as the mobile phase. There was also a Vardian liquid chromatography type 2510 utilized. Absorbance was utilized to detect the chemicals. The new method was successful in detecting the presence of multiple formaldehyde. The new purification approach reported in this work resulted in a blank level of 1 to 3 nanomole per gram for all aldehydes, and consequently a detection limit of 0.75 to 2.90 nanomole per gram for formaldehyde and hexanol respectively using the HPLC method.
The peak heights obtained were plotted against concentration after being put into the HPLC. The linearity of the calibration curves were satisfactory. The HPLC analysis took around 48 minutes to complete. The detection limit, also known as the lower limit of detection or LOD, is the smallest quantity of a substance that can be discriminated from the absence of that substance, with a given confidence level in analytical chemistry. The detection limit is calculated using the Planck's mean, standard deviation, calibration plot slope, and a specified confidence factor.
The coefficient of determination is a metric for determining how much variability in one component can be attributed to its connection with another. The goodness of fit, or correlation, is expressed as a number between 0.0 and 1.0. A result of 1.0 implies a perfect fit and consequently a very dependable model for future projections, whereas a value of 0.0 shows that the computation failed to effectively describe the data. We can see that we can trust the model presented to us because the coefficient of determination is very close to 1.0. Previous methods were based on directly treating the sample with the derivatization reagent. This required treating the fish with a highly strong acidic medium, causing undesirable reactions in the sample. This method only allows for the quantitation of the most electrophilic aldehydes. However, because the pH raised to 5.0 after 20 minutes of direct reaction and the calculated amounts of formaldehyde and acetaldehyde fell, the findings obtained may be marginally reliable.
The species Oceurus, Lit genus, Rasientron, and Rhomboplites were studied. The most commonly known member of the Oceurus family is the yellow snapper, which gives around 724 tons of fish per year, while Lit genus and Rhomboplites, commonly known as the red snapper, give around 3,000 tons per year. And last but not least, the Cobius or the Rhachycentron species give around 54 tons of fish per year. Global fish production is estimated to have reached about 179 million tons in 2018. The world's appetite for fish and fish products show no sign of slowing down. This demonstrates the significance and growing role of fisheries and aquaculture in providing food and nutrition. The fisheries and aquaculture sector significantly expanded in the past decades, and total production, trade, and consumption reached a record in 2018.
This data shows that we consume tons of fish per year. With this method of aldehyde detection, we can detect their presence without having to expose them to highly acidic mediums. Fish is filled with omega-3 fatty acids and vitamins such as D and B2, also called as riboflavin. Fish is rich in calcium and phosphorus and a great source of minerals such as iron, zinc, iodine, magnesium, and potassium. Fish show a ton of nutritional value, but this value is wasted due to the presence of aldehydes.
This new method for locating traces of volatile aldehydes with the use of high-performance liquid chromatography in the form of 2,4-ditrophenylhydrazone derivatives have proved to be effective. This new method worked as it should by detecting formaldehyde, acetaldehyde, propanol, butanol, pentanol, and hexanol and conducting the experiment.
Acetaldehyde, which gives off the fish's pleasant fruit aroma, and propanol, which originates from the breakdown of omega-3 fatty acid peroxide, are the most abundant carbonyl compounds which were found in the study. This novel method is much simpler to conduct than the other methods to trace aldehydes, giving this new method an advantage against past methods.
I think that this method is very effective in achieving what it plans to do. It gives us a way to detect the presence of aldehyde without having to expose the meat into highly acidic mediums. With this, I think we can keep the nutritional value of the fish to a higher level rather than with the previous methods.